Train A and B starts traveling at the same time towards each other with a constant speed from the station X and Y respectively. So I take the station X over here and I take the station Y over here. This is the route that we are trying to travel. A and B starts from opposite directions, trying to travel towards each other at the starting at the same time. Train A reaches the station Y in 10 minutes. So what is going to happen with the train A is they're going to meet somewhere over here and then cross their journeys, correct? And reach at these points. Similarly, B will have to travel where? B will have to travel this distance and then it will have to travel this particular distance, correct? Now understand this thing, that if both A and B are starting at the same time, this value should be t minutes and this value should also be t minutes. Watch this very carefully. At this point where they are meeting, both the train A and B have traveled for the same time. If you don't take this value as t and t, then solving this question will become almost impossible, because that's an understanding that the question wants you to have. Now train A reaches the station Y 10 minutes in 10 minutes. So if A is taking t minutes over here, A is going to take 10 minus of t over here, while the train B takes 9 minutes to reach the station X after meeting the train A. That means this particular time period over here is given to you as what? 9 minutes. Now let me demark this as, let's say, the point Z. So now if you look at the distance XZ and keep that as constant. So if you look at your formula of speed is equals to distance upon time, I'm keeping distance constant. So speed and time will be inversely proportional to each other. So speed of train A divided by speed of train B will be inversely proportional to their timings. So speed of A, what was the timings of A in the distance XZ? It was T. What was the time for B? It was 9. Similarly, if you keep the distance ZY constant, if you keep zy constant, speed of A by speed of B is going to be equals to 10 minus t over here in the denominator, and in the numerator it will be what? It will be clear. Now solving this, we should be able to get down to the answer. I look at the first equation and the second equation and I divide the two equations. When I divide the two equation, SA by SB divided by SA by SB, that will turn out to be equals to 1. So you have a 9 by t divided by t by 10 minus t. So 10 minus t will go in the numerator and t will come in the denominator. If you solve this, this is going to become t square is equals to 90 minus of 90. Clear? So this will give me what? T square plus of 90 minus of 90 turns out to be equals to 0. 15 into 6 turns out to be 90. So it is t square plus of 15t minus of 60 minus of 90 to be equals to 0. This factorization will give me what? T plus 15 into t minus of 6 to be equals to 0. So t will be either equals to 6 or t will be equals to minus of 15. T is the timing, which is in minutes, cannot be negative. So this value need to be rejected. So the total time period t, the value of t must be equals to 6. Now what is the question asking you? The total time taken in minutes by the train B. If you look at the train B over here, its total time taken will be 9 plus t and the value of t is 6. So 9 plus 6 will turn out to be what? 15 minutes. And that will be the answer for this question.